Very good, very good afternoon. Up to now, we discussed about the second unit. Now we will start our new concept, that is the new chapter, your unit 3. Uh, Up to we completely discussed about the basics, discrete signals in our first unit. Now we will try to move on, then we will study one by one. And this is the concept where we discussed classics of commonly used analog filters. At the end of the session, you will able to learn commonly used analog filters. And what the topics we discussed today, before going to that, just we studied what the concepts we needed to study up to. So still our first unit. In our unit 1, we discussed completely about the basic signals and its responses. Now coming to the unit 2, we discuss simply discrete Fourier transform IDFT with the simple calculations of FFT and IFFT. But coming to the unit 3, we discussed the concept of called IIT, infinite impulse. This is the IAR, infinite impulse response. So IIR, infinite impulse response. So what is the impulse response? We know that what is the impulse response. Impulse response means where you will give the input as a impulse. Input as a impulse. Where you will get input as impulse to the system where it is the h of n. So how output you will get. While giving the input as a impulse, what is the output you will get? That is called as impulse response. Now coming to the basic definition of IAR. What is the IAR? It is a recursive or it is a non-recursive. All the things we will be clearly discuss one to one. So first thing, you will be keep in your mind that generally all the digital filters, all the digital filters are generally, it is LTA systems basically. What is meant by LTA system? Linear time invariant. So all these are belongs to LTA systems. And basically now coming to the digital filters, we mostly discussed about the topic called as IAR filters and FAR filters, finite impulse response, that we will study in next chapter. So now coming to we only concentration on IAR filter. So what is the IAR filter? How it will be used? That all under we will be seeing. So the basic definition of IAR is IAR filters are recursive filters. IAR filters are recursive type. So what is meant by recursive type? Simply, IAR filter definition is simply present output depends on present input, okay, present input and past input samples as well as past output samples. These are the definition we studied. Means what? The present output, that we can say maybe the present output is n. Only n we have taken is a positive. So as per our definition, y of n is depends only on present, past. Present means x of n. Okay. Past means x of, for an example, you can consider x of n minus 1. And past output sample means y of n minus 1. So these are the conditions we studied. So y of n, y of n. Now the basic definition of from the definition of Iir filter we already studied. From the definition of Iir filter, so I can just define the expression. You just observe y of n is equal to what? I just take the one constant term, that is maybe b naught into x of n. Present depends on present, and b1 x of n minus 1. Present output depends on past, that we will accept. B2 x of n minus 2. Of course, it is also past. And up to so on, just take x of n minus n. Along with what? Some, along with what? We have the signals that we can take it as a present output depends on past, that is y of n minus 2. And similarly, up to so on, you will consider minus an y of n minus n. You just apply Z transform. What you will get? Apply some Z transform. You know that x of n minus n naught of Z transform is nothing but a Z power of minus n naught x of Z. Where if it is plus, and it is the plus. With that, I can apply Z transform. I will get b naught x of Z plus b1 Z minus 1 x of Z plus what? Next step 10 plus b2 minus 2 x of Z plus so on bn Z power of minus n x of Z, along with the term minus a1 Z minus 1 y of Z plus minus a2 Z power of minus 2 y of Z, and up to so on an Z power of minus n y of Z. Now take the y of Z terms are right side. To take the common, y of Z is equal to a1 Z power of minus 1 plus a2 Z power of minus 2, so on an Z power of minus n is equal to what? If you take the common as x of Z, b naught plus b1 Z power of minus 1, b2 Z to the power of minus 2, up to so on what? bn Z power of minus n. So required the term to calculate the transfer function. I require to calculate the transfer function for y of Z by x of Z. So that simply we can call that h of Z is equal to b naught plus b1 Z minus 1 plus b2 Z minus to so on, Bm Z minus M by 1 plus A naught Z minus 1, A2 Z minus 2, so on, Am Z minus N. Then next, we will segregate all these terms. Okay. Next, I write it as a pitch of Z is equal to, just clearly observe, I can write summation k equal to 0 to n pk Z minus k. I can write it as by denominator 1 plus summation k equal to 1 to n ak Z power of minus k is the expression. So simply to design infinite impulse response, simply we can call it as a coefficients like ak and bk, right? So basically, so basically these are the Iir filter concept, continuous Iir design, the discrete Iir we will be discussed, and generally characteristics of commonly used analog filters are Butterworth filter that we will discuss in next concept. Before that, we will discuss the concept Chipso filter, Chipso type 1, type 2. These designs, how the steps we will include, all the topics we will be discuss, and next class we will discuss completely regarding to some of the digital filters what already we studied. Okay, so like that question they will ask why it is defined filter. What is a filter? That all we will see in next class. Right? We will see about the filters from next class. Thank you.